Well, this is mostly for Allie, and what I want to do is take a few minutes and just make sure that you're up to speed on all the stuff that we've done so far in Chapter 5 in geometry. First part of this chapter, it introduces a bunch of specific terms, and what we're trying to do with those is make sure that you know the difference between things like midsegment, perpendicular bisector, angle bisector, median, and altitude, and the properties that some of those, and in particular, mid-segment and median, end up having. We'll take a quick look at just a summary of parts of the notes that came up so far in this chapter. So a mid-segment, the key thing is that it connects the midpoints of two sides of a triangle. So you go from halfway across one side to halfway across the other side of a triangle. It always ends up being parallel to one of the sides, and it'll be half as big as one of the sides of the triangle. So typical problems tend to look something like this one, where what it says is we know some measures and we're supposed to figure out x and y. And for example, if I know that it's a mid-segment, then 4y would have to equal 6 times y minus 1. And I also know the bottom side of this triangle has to be twice as much as the mid-segment. So the 4x minus 2 at the bottom would be twice as much as x plus 4. And you can see this all worked out on the next couple of slides that we have with these. Also turns out that if you have a point that's on a perpendicular bisector means it makes a right angle and it bisects the side. It cuts the side exactly in half. Well, if you have any point that's on that, it's going to be the same distance from the endpoints of the segment. And so if you did have something like this picture, for example, if I know I have a perpendicular bisector, then like the 15 on the left and the 15 on the right have to be the same. And I also would know that 11 would have to equal 4x plus 3. Those have to be the same. So again, if you solve that, x will end up being 2 when you do solve the problem. Distance always means how far it is perpendicularly. And it does turn out that if you have an angle bisector, an angle that's divided in half, then any point that's on it is going to be the same distance from one side of the angle as it is to the other side of the angle. So like in this picture, again, what this really is saying so far is that when you see things that look like they're probably the same, they're going to be the same. So like 2x minus 1 has to equal 3x minus 11. You can solve that and figure out in this problem that x would equal 9. The part that we just got done going through dealt with medians and also with altitudes. A median just goes from an angle to the midpoint of the opposite side. And there's a word that comes up on the worksheet that we're going through today in class that is the word centroid. It's just where the medians meet. You don't really need to know that term, but it is something that the book uses in directions. And the big thing that's important about it is that when you have a centroid, it always divides up the median into two parts, one of which is twice as big as the other. So like the big part of this is 2 parts, the bottom part's 1. Big part by the angle is always twice as big as the small part. And altitude is just a segment that goes from an angle perpendicular to the opposite side. We did perpendicular bisector before. That could be an altitude, but it doesn't have to be. The key thing about an altitude is it's always perpendicular. And it could end up being either inside, outside, or on a triangle. A term that's even less important than centroid is this one, which is the word orthocenter. That's just what you call the point where all the altitudes intersect. And so again, the terms that we've gone through so far, a midsegment, it always goes to the midpoint of two sides of the triangle, from one midpoint across to the other midpoint. It'll end up being parallel to a side, and it is half the length of the side. Perpendicular bisector, it makes a right angle, and it cuts the side in half. An angle bisector always cuts an angle in half. And in both of those things, basically anything that looks like it's congruent will be congruent. Median goes to the midpoint of a side, and where the medians intersect, it always divides things up into 2/3, 1/3. That will always be true. The part by the angle is twice as big as the part that's by the side. And an altitude ends up going from an angle perpendicular to the opposite side. So those really are what we've done so far going through the stuff in chapter 5.